Ever stop and wonder what's really going on inside you? I mean, not your thoughts or feelings, but way, way deeper, down at the microscopic level. Well, today, we're taking a tour of one of the most complex, bustling cities in the entire universe, the eukaryotic cell. So go ahead and grab your microscopic tour bus pass. Our journey is starting right now.
So, I want you to think of each one of your cells not as some simple little blob, but as a fully functioning, completely self-sufficient city. Seriously. It's got a government, power plants, factories, a transportation network, waste disposal, the whole shebang. And the most incredible part? You have trillions of these cities inside you, all working together in perfect harmony. Every great city has to have a command center, right? A place where the master plans are kept safe and all the big decisions get made. Well, in our little cellular city, that place is the nucleus. And here it is. Welcome to City Hall. The nucleus is the absolute command center of the cell, and it holds the most precious thing this city has, its architectural blueprints. I'm talking about the DNA. This is where every single instruction for building and running the entire city is kept under lock and key.
But you know, the nucleus isn't just some dusty old library, it's the active brain of the whole operation. It doesn't just sit there storing the DNA, it controls everything. By deciding which blueprints get read and when they get read, it basically directs all of the cell's activities, from growing and making energy to, eventually reproducing.
So how does that super important information actually get out to the rest of the city? I mean, you can't just let the original master blueprints leave City Hall. That'd be crazy. Instead, the nucleus makes copies, these little messages called messenger RNA, and those copies are sent out through these highly secure checkpoints called nuclear pores. It's the only way out.
All right, once those blueprints are out of the command center, it is time to build. Let's head over to the industrial heartland of our city and see how these plans actually get turned into real functional products. This here is the city's main production line. It's a three-step process. First, a blueprint, that's the mRNA, travels from the nucleus to a factory called the rough endoplasmic reticulum. Then, a little worker, called a ribosome, reads the plan and starts building a protein. Finally, that brand new protein gets sent over to the central post office, the Golgi apparatus, to get packaged and shipped out. Let's get a closer look at that factory floor. This whole network of membranes is the rough ER. And why is it rough? Well, it's because it's literally covered in those little dots, and those are the ribosome workers. All of them just tirelessly building proteins that are going to be shipped out of the cell or become part of its walls. Okay, so from the factory, all the new products are sent right here, to the Golgi apparatus. The best way to think of this is as the city's main post office, or maybe it's Amazon fulfillment center. It gets the proteins from the ER, makes a few final tweaks, sorts them, and then packages them into these little delivery bubbles, slapping the right shipping address on before sending them on their way. Now, a city can't just run on factories and shipping. It needs power, a sanitation department, and of course, a solid infrastructure to hold everything together. So on the left, you've got the mighty mitochondria. These are the power plants of the cell, and they are constantly working, generating ATP, which is the energy currency that fuels literally every single thing the cell does. And on the right, those are the lysosomes. This is the city's sanitation and recycling crew. They use these super powerful enzymes to break down garbage, old broken parts, and even chop up any foreign invaders. But what stops this whole city from just collapsing into a goopy puddle? That would be the cytoskeleton. And don't think of it as just a boring, rigid skeleton. Oh no, it's this dynamic, constantly changing network of protein fibers that gives the cell its shape, acts as a highway system for transport, and even lets the whole city move and change its form. The first part of that network are the microfilaments. You can think of these as the city's flexible support struts. They help hold the cell's shape, they can resist tension, and they are absolutely crucial for things like muscle contraction and letting the cell crawl around. Then you have the intermediate filaments. Now these are the heavy-duty steel cables of the cell. They are incredibly durable, and their main job is just to provide pure reinforcement, anchoring the nucleus and other important buildings in place so they don't just float around randomly. And finally, we have the microtubules. These are the city's major highways and railway lines. Important cargo and delivery packages use these tracks as a road system to move materials from one part of the city to another. It's all about making sure goods get where they need to go, and fast. So we've seen the power plants, but how does the city's economy actually work? What's the fundamental process that takes raw materials and turns them into that precious, usable energy? Well,
The entire city economy is run by a special class of workers, enzymes. These things are biological catalysts. Basically, they make every single chemical reaction, from building stuff to making energy, happen incredibly fast and efficiently. They do it by lowering the startup cost for those reactions. Without enzymes, the entire city would just grind to a halt.
So making energy all starts with this process called glycolysis. This happens right out in the open, in the city's general workspace. Think of it as a quick and dirty way to break down a sugar molecule, glucose, to get a small but immediate bit of energy. It's kind of like the cellular version of making a quick buck. But for the big payday, the real money, that broken down sugar heads over to the mitochondria. Inside those power plants, through a way more complex process, that one single molecule of glucose is completely processed to give a massive energy payout, around 32 units of ATP. Now that is the efficient process that powers our entire complex city.
Okay, let's zoom out from all these tiny details for a second and just appreciate the absolutely stunning masterpiece we've been touring.
To really wrap your head around our city's complexity, just look at the alternative. A simple prokaryotic cell, like a bacterium, is basically just a tent. It's got the basics to survive, but there's no nucleus, no specialized departments, no infrastructure. Our eukaryotic cell, with its command center and all its specialized districts, is a sprawling, sophisticated metropolis by comparison. It's not even close.
And that's our tour. A city with a secure government and its nucleus, factories in the ER, a postal service in the Golgi, and power plants in the mitochondria. A city that builds itself, powers itself, and cleans itself. And this isn't some far-off sci-fi concept. Trillions of these incredible cities are running inside of you at this very moment. But here's the final, most mind-bending thought to leave you with. This impossibly intricate city, with all of its perfectly coordinated processes, has no mayor. There's no CEO, no conscious director pulling all the strings. It all just works. Which leads to the big question. If there's no single leader in the conductor's seat, what is it that directs this beautiful, complex orchestra?